everybody. So I'm going to be talking a bit about Rust today. Some of you might have heard of it. If not, we'll be getting into it. OK. A little bit about me. I'm the youngest speaker this year. I'm a student. I'm a full-time engineer contractor at Apple. And I work with Rust and JavaScript all the time. Little fun fact about me, today is actually my mom's birthday. So can I get everybody to say a happy birthday to my mom? Woo. Thank you. I think she's going to appreciate that. So to level set a bit, when you see a lot of these Rust talks, I hear a lot about how all JavaScript needs to be moving on to Rust today, how there's all this stuff wrong, and that we need to be embracing this next wave of all that. And that's not this talk. I think there's a lot of arguments between which is better for which use case and where we should be using JavaScript and where WASM and all of these new technologies fit together. And that's not this. Today, I'm going to be showing some code. And we're going to be looking at some ways that we can all make our JavaScript code a bit nicer and a bit easier for us all to work together for long-term and scalable projects. So to get into it, let's look at some bad code. What you got here is about the worst function I could write. Takes in a parameter, I don't know which one, runs a few functions on the inside from those, very hidden control flow. Like, you really can't tell what's going on here. I think we've all seen these at our companies of the developer who left 5 years ago and didn't document anything. So let's make this a little better. I added types, I added names. It turns out to be a pretty simple function to get the friends of a user. This is based on a real experience I had a couple years ago, spending days trying to get this out of that code. Now, this code's a lot better. I think we can all see, takes in the session ID, gets the session, gets the user info, then uses it to get their friends and returns their friends. It's all strong typed, it's all nice, and everything works. Well, that's the big thing. Yeah. You beat me to the joke. So I ran this code, and I get this. Because as much as I tried to add types, JavaScript doesn't treat errors the same way it treats values. So somewhere in this code, there is something that's breaking down. And we could run down this stack trace. And that's what we do most of the time. That's what I spend a lot of my time doing. But I want to look into some other approaches for how we can make this a little nicer. And before starting this, I want to go in a complete side direction. This code is C++. If you guys don't like Rust, you'll hate this. So I'm going to go through it just to be sure everybody can make sense of it. Takes in a number, enter it. Then once we got that, we're just going to do a simple check. Is the number greater than 0? If that's true, let's say it's positive. It's false, let's say it's negative. If it's 0, like, all this makes sense, right? Good code. Hands if you can make sense of this code. Yeah. Except that C++ lets you set true as false and false as true. So this is a problem that you run into in C++, where you can look at any set of code, and you can never really be sure what's going on. And that can happen in JavaScript with these errors. You get one error in one small component, in one file, in one tiny feature some guy across the world is working on, and it'll take down your whole system. So we could try catch, but I mean, there's a lot of React devs here I've seen. We've all had those like simple one button that you press it and then the whole page freezes. And that is a virtue of the way JavaScript works. So we're going to look into a few other ways that these are handled and see the philosophy behind them and if we can make it work better for us. So the first thing we could do to try to make this better is this. We could wrap every single thing in a try-catch, which is frankly what I end up doing when I'm debugging. But it's kind of tedious, you know? This isn't nice code. This isn't very useful code. And because TypeScript doesn't offer typing on errors, you're kind of just out in the wild trying to deal with this. And again, there are ways and there are times for this. But it's not the only way. So let's look at some other options. This is Golang. Golang does something really unique in its error handling systems. When you look at Golang and you have a function that can fail, you actually return 2 values. You can think of this as almost the state and use state, except it's value and error. If you take the value, if it's a success, you get a value. And if the error is there, you get that. So it's either null and error or error and null, which is a way of treating the error as a first-class object, which means that the error isn't a special error thing. It's just another same Golang object that you can iterate on, that it is another path. But it's secondary. There's 2 separate things, and you can see the errors beyond the main data. So Rust does something that I find really weird and I really appreciate. Rust creates this type called a result. A result of a function is just an enum. You either get the value OK, or you get error. So to go through this way of doing the code, it's a similar code to that JavaScript try-catch I showed. But I want to emphasize the philosophical difference behind writing this code and the thought behind it. So this match statement is the same as a JavaScript switch, except it uses patterns instead of values. So we match the session, and if it's OK, we take that session and we put it into that value. And if it's error, we do that error. And we go through that with the user info, and finally the friends before we return the friends. And what I really want to emphasize here in this big philosophy is that the error is a first-class citizen. What that means is that in JavaScript, when we get an error, it's like the fire alarm has been pulled. Stop everything. That means we're going to go up the stack trace until there's a try-catch somewhere, which is why we get these big errors that can stop everything. And there's a time for that. There's real value to doing that. But that's not always what we want. Sometimes we might want to do retry logic based on the errors we get, which is very tedious in JavaScript, which is where Golang gets a lot better at this. Golang, with their separate error object, treating the error as another full object, they give you this ability to treat the error very nicely as a, by the way, quick show of hands, Golang fans, anyone? Woo, I see you. They treat the error as a separate path, you know? But what I really love about Rust is that the error isn't secondary. This is the full Rust code behind a result. What I want to emphasize here is that T and E are just typed parameters, and they could be anything. You could switch error and the type, and these are just objects, you know? Which is a really good way to think about errors in our code. Things, the way I like to see it, they don't always go wrong. They just go in a different direction. And what this philosophy from Rust that I'm hoping that we can bring into our TypeScript, as I'll show later, is that we can treat these as equal paths, as another way that your code can run. An error might not be something going wrong. It might just be something going differently. And to really illustrate that, this is another form of result in Rust. And you can see I've just built it myself with all of my separate paths. We have talk went OK, talk went well, talk with the way it's going, and maybe there's an error. And what I want to emphasize here is the error is just one path. And if there's an error, maybe my flight got delayed, so I might want to get another flight. But that's not a different thing than any of these others. They're kind of just a different way of getting to it. So let's get to the fun part, what we're all here for, JavaScript. Honestly speaking, I haven't written raw JavaScript in over 6 months. I'm a big TypeScript guy. TypeScript fans? Woo! If you are on JavaScript, I highly recommend you move over. It's worth it. So this, what I'm showing up here, is that same Rust type with that same reliability of these separate paths, of the talk had an error, and instead of me short-circuiting, I got on a different flight, you know? And this is the advantage that you get when you handle errors as objects, that you treat them with their own unique properties, that you're able to switch and use the other rest of your code on them. And maybe you're going to want to retry some. Maybe you're going to want to pull the fire alarm and stop the program for some of the others. But putting it here is generally a net good, in my opinion. So this is a rewrite of that original function. I promise, this is the last time. But here, we are taking another direction on it. Here, when we debug it, we're treating it as a single failure in a single piece. Now, when this fails, if there isn't a try-catch around it, it's not going to stop the functions around it. It's not going to bubble up and pause your site. Instead, what you're going to get is you're going to get a simple error that tells you what went wrong. You could add types here if you wanted to do special logic. For me, when I was picturing this, I was picturing simply a display that shows it without an error boundary, without anything special, and without any of the JavaScript error and event types that you normally have to go through. So let's get into the ways that we can make this happen on our teams. Now, the first thing is this, strict mode in JavaScript. I have forced every single team I've ever been on to use this, and you should too. Unused variables are the bane of my existence. Errors like this are the bane of my existence. And strict mode fixes a lot. It forces you to add types to everything. But the fact is, strict mode actually doesn't force you to stop errors. So the code I showed before, I won't go all the way back to it, but that code actually passes strict mode. So we're going to look into a few approaches now, based on the Rust models, to make our code more reusable, and again, safer with this same methodology. So traits are the Rust equivalent to classes, even though they're completely different. So this is a vehicle tree. I'm sure we all in our CS3 classes or wherever have sometimes had to build the tree of animal types, where the dog barks and the cat meows. And we have to construct these trees. And that's the object-oriented approach. I want to bring in a new one. This is the functional approach. And when you think about cars in a functional approach, you're not thinking of it as a top-down tree. You're instead thinking of it as the traits of it. So instead of describing a car by all of the things that derive into that car, all of the cars above it, vehicle, bike, all those, you're describing it by the things that make it up. So you could have a speed trait. You could have a weight trait. And you could have each of these. And you can compose your vehicles based on them. And I'll show this in code so we can feel the advantage a bit better. So this is the animal demo I just went through. Fairly simple, you know? And this is the composition demo. Now, it's a little longer, but I want to emphasize the coolness of the way this works. Now, picture the biggest, most annoying tree you've ever worked with of all the mammals. But we forgot a link in there. Suddenly, we're going to have to shift this whole tree down. You know, we're going to have to add a new layer and all of that and all the problems that come with it. The advantage to structuring your code like this, coming from the Rust side, is that when you want to add barking to something, it's not a subtype of dog. A dog is a kind of barking animal, which means that while with object-oriented and inheritance-based thinking, you kind of are bound to get this right on your first try. If you don't get the tree right, you're going to have to do a whole bunch of reorganization and restructuring and reordering all of this. With this, when you make a mistake, it's really nothing, you know? If you forgot barking, you just add barking to whatever needs to bark. And that goes for anything. So consistency is the next thing that I want to hit on about this. So each of these is really, really good when you use it right. But it doesn't work when you do one of these and half of the others. So when I went back to the TS config example, that doesn't fix your error handling. Golang error handling is a brilliant model that works really well for many teams. And Rust error handling and JavaScript error handling, these are all very good things. My big feeling coming off of a team that is migrating an app from JavaScript to Rust is that you have to commit to one. Because when you have these multiple ones, you run into these problems where errors don't act the way you expect. But building with all either object-oriented or moving over to traits, committing to these is where the advantages are really felt. So we're getting into the last cool thing I want to hit on that is something I learned about from Rust. This is a diagram from my math class. It's a good understanding of how pure functions work. So a pure function is a function that is the only kind of function in languages like Haskell. And it's a kind of function where for every one input, there is only one output. So the inputs parameters to a function precisely define where the function's going. This can be really tedious sometimes, as you end up having a lot more parameters than you might expect. But it provides some real advantages. So to give a more concrete feeling on what this is an impure function. Takes into account, but it doesn't take it in. So when you increment the count is coming from outside. So if you ran this function 10 times, you'd get 10 different outputs. Now, this is the pure equivalent of that function. It takes in a value, and it returns the value. Now, this is how functions work in Rust. And the big reason I really, really love this is testing. Holy shit, this makes your testing life better. So when you want to test an impure function, you'll run into issues where you need to get the state around it into the right place. You're testing a function, but you can never really test it on its own. You're always testing the environment. And the advantage to these unit functions, or to these pure functions with unit testing, is you can run the test with 10 different inputs by simply changing those inputs. And you can precisely understand exactly where everything's coming from, where everything's going, and all of that. So I'm ending a little early here, trying to get us to lunch on time. But I want to get through what I'm really hoping to convey here. JavaScript is an awesome language. But my team, at least, we've been working on a 6-year-old code base for as long as I've been there. And as these code bases get bigger and larger, they get really, really hard. And I think the appeal that a lot of developers are feeling from Rust is this feeling that Rust code forces you to maintain it. That Rust will not let you write these bad code, let you throw these errors that blow everything up, that is in some file that I was never aware of. But that's not actually true. For all that cool stuff I was talking about Rust, I can pull the fire alarm and blow up the whole program with this one line. This is all it takes for me to, if there's an error here, the whole thing shuts down. So there's a time for Rust, and there's a time for all these languages. But what I hope you take from this talk is generally the feeling that using these strategies of treating errors and treating secondary paths as just another path, as an equally valid direction your program can take, that your functions, again, can be this simple, easy way to manage these paths, that they don't need these outside states, and that through these strategies, you can build a more reliable code base, where for most teams, there's never any reason to change to Rust through these guidelines. That's the talk. I want to give a quick obligatory shout out. I am at Apple, but I actually put in my notice last week. I have left to go full-time on my new startup. So if any of you guys like JavaScript and cloud, I'd love to talk to you about this. We're in beta right now. Thank you.